Hello everyone, welcome back to my channel. I'm Brinda R, first year CSE student of Sri Venkateswara College of Engineering. Today I'm here to explain you about the topic Bisection Method and Lagrange's Inverse Interpolation Method. The contents of this video will be Introduction to Bisection Method Algorithm, Example problem related to Bisection Method and Introduction to Lagrange's Inverse Interpolation Method. Bisection Method. In mathematics, the bisection method is a straightforward technique to find the numerical solution of an equation of one unknown. Among all the numerical methods, the bisection method is the simplest one to solve the transcendental equation. The bisection method is used to find the roots of a polynomial equation. It separates the interval and subdivides the interval in which the root of the equation lies. The principle behind this method is the intermediate theorem for continuous function. It works by narrowing the gap between the positive and negative intervals until it closes in on the correct answer. This method narrows the gap by taking the average of positive and negative intervals. It is a simple method and is relatively slow. The bisection method is also known as interval halving method, root finding method, binary search method, and dichotomy method. Let us consider a continuous function f which is defined on the closed interval a, b is given with f of a and f of b of different sign. Then by intermediate theorem, there exists a point x belong to a, b for which f of x is equal to 0. Follow the below procedure to get the solution for the continuous function. For any continuous function f of x, find 2 points, say a and b, such that a is less than b and f of a into f of b is less than 0. Find the midpoint of a and b, say t. T is the root of the given function. If f of t is equal to 0, else follow the next step. Divide the interval a, b. If f of t into f of a is less than 0, there exists a root between t and a. Else, f of t into f of b is less than 0, there exists a root between t and b. Repeat the above 3 steps until f of t is equal to 0. The bisection method is an approximation method to find the roots of a given equation by repeatedly dividing the interval. This method will divide the interval until the resulting interval is found, which is extremely small. So let us see an example problem related to bisection method. The question is, determine the root of a given equation x square minus 3 which is equal to 2 for x belongs to 1, 2. Given x square minus 3 equal to 0. Let f of x equal to x square minus 3. Now find the value of f of x at a equal to 1 and b equal to 2. F of x equal to 1 is 1 square minus 3 which is minus 2 that is less than 0. F of x equal to 2 is 2 square minus 3 that is 1 which is greater than 0. The given function is continuous and the root lies in the interval 1, 2. Let t be the midpoint of the interval, that is t equal to 1 plus 2 divided by 2, t equal to 1.5. Therefore, the value of the function t is f of t equal to f of 1.5, that is 1.5 into 2 minus 3, which is equal to minus 0.75, which is less than 0. That if f of t is less than 0, assume a equal to t, and if f of t is greater than 0, assume b equal to t. F of t is negative, so a is replaced with t equal to 1.5 for next iterations. The iterations for the given functions are, first iteration a is 1, b is 2, t is 1.5, f of a is 1 minus 2 and f of b is 1, f of t is minus 0.75. For second iteration, a is 1.5, b is 2, t is 1.75, f of a is minus 0.75, f of b is 1, f of t is 0.062. For third iteration, a is 1.5, b is 1.75, t is 1.625, f of a is minus 0.75, f of b is 0.0625, f of t is minus 0.359. For fourth iteration, a is 1.625, b is 1.75, t is 1.6875, f of a is minus 0.3594, f of b is 0.0625, f of t is minus 0.1523. For fifth iteration, a is 1.6875, b is 1.75, t is 1.7188, f of a is minus 0.15323, f of b is 0.0625, f of t is minus 0.04557. For sixth iteration, a is 1.7188, b is 1.75, t is 1.7344, f of a is minus 0.0457, f of b is 0.0625, and f of t is 0.0081. For final iteration, that is seventh iteration, 1.7188, b is 1.7344, t is 1.7266, f of a is minus 0.0457, f of b is 0.0081, f of t is minus 0.819. So at the seventh iteration, we get the final interval, that is 1.7266, 1.7344. Hence, 1.7344 is the approximate solution. So the second topic is Lagrange's inverse interpolation method. In interpolation, given the data points xi, yi, where I equal to 1, 2 until n numbers, one estimates value of the dependent variable y at some intermediate value of x. For example, suppose x represents the time and y of x represents the distance traveled by a car in time x. That is, yi's are the distance traveled by a car in time xi. Then in interpolation, one attempts to estimate distance of f of x traveled in time x in the domain of observation. However, quite often one may need to find out what time car has reached a particular spot at distance y within the minimum and maximum of distances y of 1, y2 until yn. The technique of finding an estimate value of an independent variable x corresponding to a given value of the dependent variable y within the range of observed value of y is called as inverse interpolation. At the outset, it appears that inverse interpolation can be achieved by interchanging the role of independent variable x and dependent variable y and interpolating x on data points yi, xi, which is equal to 0, 1 until n. However, this may not be feasible unless the observed values of y, namely y0, yn until yn, are distinct, as almost all interpolating techniques require that the interpolating nodes be distinct. In observing any process involving an independent variable x and dependent variable y, it may be possible to impose some conditions like conditions on the independent variable x, but values of y dependent on the process being observed, and no control can be exerted on the value of y. Thus, in this particular approach for implementing inverse interpolation can be used on the process for distinctness of value of x ensures distinctness of corresponding values of y. And in this case, one can use either Lagrange's or Newton's divided difference interpolation formula. W of y is equal to y minus y0 into y minus y1 until y minus yn. It is easy to observe that this formula gives the value of x for a given value of y. This formula is known as Lagrange's inverse interpolation formula. Thank you for watching my video. Like and share the video.